Alright, welcome back. So another sick video coming. Hopefully the audio is okay. So I'm gonna have to go camera off again, so shut that down. There we go. So audio doesn't look too great, but hopefully it's not terrible. Alright, so let's take a look at the last video I did. Alright, so, oops, and I went to the wrong page. Okay, here we go. So the last video I did, I read more about the mathematics of machine learning, and that was a fun video because I figured out how to use I have a Samsung Galaxy Tab A that I bought more than 10 years ago. And at that time, it was the best thing I ever bought. It wasn't even like the newest, latest thing as far as I understand. It might have been, but even today, it holds up really, really well. It's just a really good. I'm so happy with it, and I figured out if you click on you can set up a wireless display like that, and then I can share my tablet. There we go, and now I can do. Now my mouse gets trapped in it, but if I hit Alt Tab, then it frees up my mouse. But now I can do, since I'm doing mathematics of machine learning, and even if in other network engineering stuff, now I can draw out. So like if I'm talking about if I'm trying to teach like what is a multi-chassis port channel for instance, it's a port channel where you have uh you can have it across devices like that, and then you need like a data device, or you can even have a port channel so that so you can have different kinds of port channels. You can have one device. You can have one that's multi chassis, like that, and then you can have one if the device has different. If it's a modular device and has different cards on it, you can have them going off like that. So for some of this stuff, you really can't put it to words. You just have to draw it out and show it, and that's the easiest way to explain what's going on. And the other thing we learned that I can do with this, and this is absolutely mind blowing. This is why I would say, oh, and sorry. Okay, so the thing is, the Smart View connection just randomly ended. Um, Now I thought I figured that out, so I'm gonna start the Smart View connection again, and I'm gonna show why I thought I figured that out. So you can see my whole tablet screen here. So if I go to Settings and I go to About Tablet, there's a secret code where if you click on the version 1, 2, 3, 4, 5, 6, 7, um, oh, maybe it's not the version. I forget what it is, but there's a secret code where if you click on something 7 times, I think it's the build number 1, 2, 4, 5, 6, 7. Yeah, so see in the bottom there, it says developer mode has already been turned on. So you turn on developer mode, and now you can turn on some developer options. And I thought what I did was I made it so that it wouldn't just randomly stop that connection. But obviously that didn't work. I guess I'll increase my buffer size. Maybe that might help. I don't know if it'll help or not. But you can plug it in through USB as well. Different things to try, but yeah, I just hope that's inspiring to anyone watching. It's like you don't have to go out and buy, $1,000 best thing they have. You can use what you already have. You could probably even do this with a like an old phone that you don't use anymore, you can go and buy a $10 stylus, and then you can uh, use this wireless display program to share your screen on your phone, and then just pull up whatever free app there is, and then you can draw on an old phone that you have laying around that you don't use anymore. So, being crafty with what you have is kind of something I'm all about. So, okay, so unfortunately it does have that problem where it stops sharing randomly, but that's okay. We'll see. We'll see if it's not too disruptive going forward. So the other really cool thing I can do, we can see here I drew a smiley face. We can go to, and the mouse gets locked in there, but you can unlock your mouse and use it again by hitting Alt Tab. So now I can go to the snipping tool to take a screenshot. There we go. And I can take my drawing here, my notes, and now I can give my hand-drawn stuff over to ChatGPT. And look at this. ChatGPT knows that this is a smiley face. See? I see you uploaded a simple drawing of a smiley face. Isn't that... Doesn't that just... I mean, for me, it's like... What's that mind-blown meme? I mean, I have to... Yeah, this is just... There's nothing... Like, yeah. It is definitely the epitome of this mind-blown meme for me, that it knows this is a smiley face. Isn't that crazy? So what else does it know? It know if you're doing math, this is the easiest time it has ever been in all of human history to learn math, because let's try to do a very simple problem. Let's do x equals 4x plus 2, and then let's do x minus 2 equals 4x, and now we're gonna forget to do it on both sides. So we're gonna see if it can so we're making a mistake here. We're forgetting to do it on both sides. So now we'll remember to do it here. So we'll remember to do it here. We'll do minus x, and then we'll do negative 2 equals 3x plus 2, and then we'll do minus 2, so negative 4 equals 3x divided by 3 divided by 3. We're going to do x equals negative 4/3. There we go. So see that? Why is this the easiest time in history to learn math ever throughout human history? Because look at this. I go in this here. This is my handwriting. I drop it into ChatGPT. I don't even have to type because I can just use my voice. Can you double check my work on this math problem? Did I get it right? Look at this. So let's double check the math. So I subtract 4x. So yeah, so I got it wrong. So right there, you can go back and look through it yourself. But do you have any idea of where I went wrong? I thought I was doing it right. So I started with that. There we go. Then I didn't keep the yeah, so yeah, it would be to subtract 4x from both sides, but I only subtracted it from one side. So in your work, it looks like there might have been a mix-up in simplifying and subtracting constants and variables. Either the arithmetic or setup misaligned in one of the middle steps. So you need to subtract things from both sides. So a common error is not carefully tracking signs or mixing up constants and variables. It looks like your main mistake was subtracting and handling terms, mixing that unintentionally. Can you list out the names of the mathematical principles involved in solving this problem? Look at this, and now it's all there. Like the textbook won't even have that. The textbook will just assume you're not going to go back over probability, equality, property of equations. It's just assumed you already know that. You're not going to go back through, um, combining like terms and all this. Like it's easier if you have any gap in your knowledge. If you've never seen anything like this, you forget what this is. You just get refreshed instantly. You know exactly. It's all right there in one location. You don't have to go flip back through the other chapters. You don't have to go flip back through the old textbook from the easier courses. It's just all here in one-stop shop, one location, and you do it yourself. You write down on your device. You take a screenshot of it. You feed it into the AI, and then you have a conversation about how you did, and you learn math. Like, what an extraordinary time we live in. So you could probably even have it teach you to draw better and stuff, and teach you to do all kinds of things, to teach you how to write in a different language, teach you how to write mathematical symbols, or it's just absolutely the times we're living in, and this is the most primitive it'll ever be for the rest of our lives. It's just here we go. This. All right. So yeah, let's make some more progress. And this is kind of, I'm always kind of at a loss for what actually makes sense to do. Unfortunately, I will say this probably, and I've been very inconsistent in doing this, because the cold hard truth just really genuinely is that this is not really, doesn't make sense for me to do. By the time machine learning really blows up, we're at the very beginning cutting edges right now. The math, I'm sure, will be like a bit different. Like it'll like, I don't know. I just feel like so many things are going to change in society that learning the mathematics of machine learning doesn't really matter that much. And then my current career trajectory has not been machine learning. It's been network engineering. I started this channel to try to get the JPR-961 exam done, and then since then I've read books about network engineering. I'm going into my second decade of experience working at network engineering jobs. So I should be going for certifications. I should be learning about places where I may have a bit of a gap, such as like my experience has been service provider networking, so broadening out into cloud, broadening out into things like site reliability engineering, into things like 5G would be great. Even just so we can see, we've got a lot of things going for some NVIDIA certifications. So yeah, I kind of have to. It's hard for me to go on with this, because unfortunately it's a little bit misaligned with my current trajectory, which is a bit problematic. All right, but anyways, let's try to get a bit done here. We're gonna learn about matrices, and it'd be nice if there was a clear stopping point or something to try to aim for. But as I said, this is just pretty low on my totem pole of priorities. It just doesn't, I think, matter that much to me that I know the mathematics of machine learning, unfortunately. Alright, so this is section 2.2. It's about matrices. Matrices play a central role in linear algebra. They can be used to compactly represent systems of linear equations, but they can also represent linear functions, linear mappings, as we will see in section 2.7. Before we discuss some of these interesting topics, let us first define what a matrix is and what kind of operations we can do with matrices. We will see more definitions of matrices in chapter 4. Alright, so we're going to learn all about a matrix. The definition of a matrix, definition 2.1, with m comma n. Okay, so one of my favorite things to do with ChatGPT is to unpack the terms. So let's use that prompt, and I've really had that prompt down to a science before. So let's see if we can get the exact same prompt I used before, because and then put it in my Google folder, because it well, it's been a while since I've done a video. It's been a while since I've done. I mean, that's okay. It's not hard to come up with a good prompt, in my experience. So, okay, so there we go. I'll finish reading this. There we go. So with m comma and yep. So in a real value matrix, A is the tuple of elements, which is ordered according to a rectangular scheme consisting of m rows and n columns. By convention, A comma n matrices are called rows, and m comma n matrices are called columns. So we have rows and columns here. These special matrices are also called row/column vectors. So, and this R looking symbol, which is not an R, we'll see what it is later, is the set of all real valued m comma n matrices, and then this symbol here can be equivalently represented as that by stacking all n columns of the matrix into a long vector. See figure 2.4. Okay, so let's feed it. Let's go ahead and feed it this whole section here, and then we're gonna feed it the 2.4, and then we'll come up with a prompt to get that in plain English and see if we can make sense of it from there. Alright, so okay, so now the prompt is going to be rewrite the text shown in the screenshots so that there are no longer any mathematical symbols, and instead there is the English that you would unpack to describe the symbols. So for example, a simple algebraic equation could be x equals 4. So, but that, you know, the character x and like the equal sign, that's a mathematical symbol. So you would unpack that to say a quantity we don't know equals 4. And then you could even go on to say that therefore we know that this quantity that we thought we didn't know, we do know because it equals 4. You know, so like, I want you to take away all of the mathematical symbols and instead replace it with plain English. But then when you are done, I want you to include a legend that maps the symbols with the plain English, so I can better understand what the symbols mean after I read the plain English. Alright, so that should be a good enough prompt. Okay, so now let's read this again, and it's going to be in plain English. There we go. So this is a set containing all possible arrays of size m by n, where each item is a real number. Okay, so now here's the real definition. Consider two positive whole numbers, which we call m and n. A rectangular array, which we will call A, is composed of m horizontal arrangements of items and n vertical arrangements of items. Each of these items, denoted as A subscript I subscript j, refers to the number found in the position where the ith row and the jth column intersect. For example, the array could be written as follows. The first row contains a first number, a second number, and so on up to a number in the nth column. The second row follows the same pattern. This continues until the mth row. When referring to a single number within the array, it is common to identify its position using two indices, the number of the row followed by the number of the column it resides in. Now, if the array only has one row, it is referred to as a row vector. Conversely, if the array only has one column, it is referred to as a column vector. There exists a special way to represent the set of all possible arrays of size m by n filled with real numbers. A single array in the set can also be transformed into a long list of numbers by stacking its vertical columns one beneath another. Figure description. An array that has 2 or 4 columns labeled as A can be reshaped into a list of 8 numbers by placing all numbers from each column below one another. Formula explanation. There is a specific process known as the Einstein summation convention that helps to combine arrays efficiently. In this case, a particular formula describes how to combine the arrays A and B by summing over specified positions. That's something that surprised me in high school physics. Is Einstein did a lot of things. It's not just E equals mc squared. It's like that's just one of his major game-changing accomplishments in his career. Alright, so here's the legend. So we've got a positive. There we go. Alright. Okay, so oh, you know what? Here, okay, I feel like this really makes things a lot easier to understand here. I wonder if there's a way I can blow this up a bit to make that easier to read. Um, yeah, if I zoom in. There we go. Yeah, if I just keep zooming in, which will take a while. I'll use the hotkey, so Control++. There we go. So yeah, so we can see now, this symbol refers to this sort of thing, and then we can see what it actually is by the denotation up here. So we can see it's a 4x2. We've got 4 rows. Each row has 2 columns. And then here we've got a I can't see what this character is, but we've got a different symbol that represents the different layout. So it's more clear what this means now, and we can see. Yep. So there we go. All right. So moving on to 2.2.1, matrix addition and multiplication. The sum of two matrices. So this represents a matrix. But this is with there and this, yep, so different. Okay, is defined as the element-wise sum. For example, okay, for matrices, yep, the elements there of the product that are computed as this. This means to compute that element there, we multiply the elements of the ith row of A with the jth column of B and sum them up. Later in section 3.2, we will call this the dot product of the corresponding row and column. In cases where we need to be explicit that we are performing multiplication, we will use the notation A times B to denote multiplication, explicitly showing that dots to show that they're being multiplied. So I've definitely heard of the term dot product before. There are n columns in A and n rows in B, so we can compute that for that equals 1. Commonly, the dot product between two vectors A, B is denoted with this T symbol, or like that. Alright, so let's read down to the example, and then I need a break. Remark: matrices can only be multiplied if their neighboring dimensions match. For instance, an n times k matrix A can be multiplied with a k times n matrix B, but only from the left side. Okay. The dot product BA is not defined if m does not equals n, since the neighboring dimensions do not match. Remark: matrix multiplication is not identified as an element-wise operation on matrix elements. For example, okay, even if the size of A comma B was chosen appropriately, this kind of element-wise multiplication often appears in programming languages when we multiply multi-dimensional arrays with each other, and it's called a Hadamard product. Alright, so that's a key term, I think. So let's highlight it and then move on. So don't want to use this because it's the same color here. I might accidentally delete it. So we'll highlight it in orange. And let's just briefly look at the... so we'll go to my orange highlights, which is this. Oh, and I can't copy it. Oh, okay. So to copy from Kindle, you highlight it, then you let go of the mouse. You don't push any other buttons, and then you hit copy. And it includes the author information, which is really annoying. But that's okay. Okay, so now we got the Wikipedia article for that. That's usually a good place to start. And then whatever is better to go is likely in the citations. Khan Academy is also a good one. I really like what Khan Academy does. So we've got Khan Academy up there, so we can see if Khan Academy has anything to say about it. Nope, this is beyond. Khan Academy's flaw is that it's for kids. But just because it's for kids doesn't mean it's a bad resource. In fact, sometimes, kids are the ones that are usually the target of education. So educational resources for kids are probably sometimes better. Alright, but the Wikipedia page looks like a really good thing to be aware of. Alright, so next is the example. So I need a break. I'll be right back. Alright, I'm back. Let's make some more progress. Usually I'm good for about an hour, although I am Very, very, very sick. Okay, so let's see if well, I don't need to share my tablet yet, but I'll get that going. Now there is a example here, so the examples can be useful. All right, so it's not connecting, unfortunately. Direct Wi-Fi to use Smart View. Turn it off. Okay. Okay. All right. Back in business. So this is an example. So, and my mouse got captured, so that's just an Alt Tab. So, this is a bit of a hands-on. So let me draw this out, because that's yeah. So for a equals 1 2 3 3 2 1. Okay. All right. Comma. B equals 0 1 0 2 negative 1 1. We obtain. Okay. So yeah, I'm very, very lost. I wish I could find my old ChatGPT conversation for what I did with the other example, because I feel like that helped a lot. But that was, I think, a lot easier than this. Because right now we're putting oh, you know what? The first part of this is actually really easy. It's just putting them side by side, so I can do that without knowing what I'm doing. Yeah, so AB side to side would just be drawing them side to side. So 1 2 3 3 2 1, and then 0 1 0 2 negative 1 1. Okay. Yeah, so that's not bad. But then we need to know why it equals, why that's the same thing there. Oh, and yeah, so let's just feed my drawing into ChatGPT. new conversation. Alright, and let's see if we can get that right. Just thinking about it. Oh, so there's an error. It didn't understand. Ah, here we go. So, perfect. Wow, isn't this amazing? And it got everything right. Wow, just from my hand drawing. I gotta leave that meme up of mind blown. Got everything right. Okay. Alright, so explain how you did how you came up with the product, and you know, give me the, like, names of the principles behind it, and spell it out for me for how I can do it myself by hand. Alright. So the dimensions, so first we ensure that they can be multiplied. So in order for them to be able to be multiplied, the number of columns in A must equal the number of rows in B. So let's check that in my drawing. So the number of columns in A, there are 3 columns. Yep, and that equals the number of rows. Perfect. Says the number of columns in A equals the number of rows in B. The multiplication is valid. The resulting matrix AB will have dimensions 2 by 2, rows of A by columns of B. How do you know that the resulting matrix AB has dimensions 2 by 2? Okay, so there's a rule for matrix multiplication dimensions when multiplying 2 matrices. If A is of dimensions... Write this out way more, like, intuitively, so, like, I could have the necessary intuitions to, like, develop this on my own if, like, all the textbooks tomorrow were burned in a large fire. Okay. Yeah. So, what does matrix multiplication mean? Oh shoot, I dropped my tablet there. That should be fine. So step 1, what does it mean? Think of matrix as a way of storing information about relationships. Each row of matrix A could represent some kind of input or resource, and each column of matrix B could represent some kind of output or transformation. The resulting matrix AB represents what happens when these inputs flow through these transformations. Step 2, rows and columns are building blocks. Imagine you're trying to build this result by hand. Rows of A tell you, here's a set of things I have. Columns of B tell you, here's how we transform or use those things. To figure out the effect of combining A and B, you're essentially asking, how does each row of A interact with each column of B? Let's get it read out.
Got it. Let's build the intuition from the ground up, imagining you're discovering this principle yourself without relying on formal rules. Step 1. What does matrix multiplication mean? Think of a matrix as a way of storing information about relationships. Each row of matrix A could represent some kind of input or resource, and each column of matrix B could represent some kind of output or transformation. The resulting matrix AB represents what happens when these inputs flow through those transformations. Step 2. Rows and columns as building blocks. Imagine you're trying to build this result by hand. 1. Rows of A tell you, here's the set of things I have. 2. Columns of B tell you, here's how we transform or use those things. To figure out the effect of combining A and B, you're essentially asking, how does each row of A interact with each column of B? Step 3. Align rows and columns. Think of it this way. Rows of A tell and columns of B as are like pairs of instructions. When you pick a row from A and a column from B, you're matching them up to see how much output each input generates. For example, if a row in A says I have 1 of thing 1, 2 of thing 2, and 3 of thing 3, and a column in B says to produce one output, thing 1 contributes 0, thing 2 contributes 1, and thing 3 contributes 0. You would multiply the corresponding values and sum them to see how much output this pair, row and column, generates.
2.
Step 4. Building the resulting matrix. Now, let's think intuitively about the size of the resulting matrix. When you're matching, each row in A has a conversation with each column in B to produce a number.
All right, so that makes sense. So for each, okay, so you have for each row, you apply the operations in the column. So we have a row here, 1, 2, and 3, and we can see we're not using the 1, we are using the 2, but we're not using the 3. So the value here would be a 2. And then for wait, and then this would be a 2 also. So let's see if that's right. A 2 and a 2. No, it's a 3. Man, this is tricky. Because I don't know like what the convention is for like where you put the number after it's been. And I don't know that this is like multiplying them. You know what? I think I'm too sick to continue. So let's I'm gonna bookmark. Move the bookmark. When I come back, I guess we'll spend more time on 2-3. But honestly, I can't. I feel like I'm getting distracted. This is just not. This is not. There's nothing on the other end of this. Unfortunately. And then by the time I actually really nail it, like the AI, it won't really matter. I feel like it doesn't matter. I need to be focusing on something more immediate. So that's it for this video. Thanks for watching. See you in the next one.